Hey everybody, this is Rydo and we're back to Human Resource Machine. Let's hop to it. Select my employee ID. So let's do 23 now, the littlest number. I assume they're going to want the littlest number. To reduce our carbon footprint, management is requesting the smallest numbers only. This is a public relations exercise. The results are going straight to the landfill. Yeah, that doesn't reduce your carbon footprint any. For each zero terminated string in the inbox, send to the outbox only the smallest number you've seen in that string. You will never be given an empty string. Reset and repeat for each string. What's a zero terminated string? Go ask your boss on the previous floor. Tell me more. If you want to buy a sandwich and there are 10 sandwiches listed on the menu and you don't have much money because of our poor financial decisions, how do you find the least expensive sandwich? Don't ask me. I bring my own lunch, peanut butter and jelly. Give me an example. And clicking the give me example has a tendency to fall right off the edge. If your inbox says 8, 10, 1, 0, of that 0 terminated string, 1 is the right answer. 12, 10, 8, 1, 0, of that string, 1 is the answer. 39, 72, 96, 46, 56, and 0, 39 is the smallest. Okay. I think we can do that. What's our optimization here? 13 or fewer commands? Pretty easy. Let's see. Let's copy it to number 1, the first number. And anytime we inbox, we're gonna have to jump a 0 to be ready to outbox. And we'll probably outbox always from the first number, I would guess. And so next thing we're going to do, well, actually it says you'll never be given an empty string, so we don't even need to jump if 0 on that case. We'll just jump if 0 here. Inbox, subtract this. If it's negative, go like here. It saves you a few steps to check if a number is negative over checking if a number is 0, because in likelihood you're going to get a more negative numbers than you would 0 numbers, or in this case you're going to get more positive numbers that you subtract to get more negative numbers. And so if this is negative, I'm going to just add that to get the number back and then copy it here. And I think that's probably the opposite of what I need to do. But let's see. This will give us 12 codes of potentially 13. So we get a 5, we put it here. We get a 13, we subtract. That's a positive number, that puts it down, and that's doing the opposite of what we want, is keeping the bigger number. And then we need to put a jump of 0 here to get to this point. So it's not do it when when the number's negative, it's do it when the number is positive. So if we test for negativity and it fails, it will go here. If we test to see if it's 0, we go here. Actually, if it's 0 when we subtract, we don't need that code at all, because that would just mean it's the same number. So we don't need that. Let's try it now. 3 gets put here. We subtract this. That's a positive number. That tells us nope. Really? Oh, I think I figured out the problem. I was right the first time, but I didn't have a jump here to get back to this point. So now that should fix it. Three gives us a positive number, jumps it. 3 gives us a negative number, so it puts that down. There we go, we've got the smallest number in that set, we outbox, and I believe we can probably just skip forward here. 13 lines of code. Let's just see if it works. So we did it in 13 or fewer. Seems a little easy, particularly compared to the Fibonacci sequence. And there's nothing more I need to do. I also achieved the speed challenge. That makes it nice too. So yeah, that solves that problem. Littlest number. Let's do mod module now. The way they're numbered, they imply they want you to do these in this order, and it feels like the story is even sometimes written that way. But then they definitely go from a very easy puzzle to a somewhat hard one. How many hours of work can you fit in one day? Well, 24. Not enough. There's always a sad remainder of the unworked hours. Good thing we have those optional night shifts to cram in more. So, for each two things in the inbox, outbox the remainder that would result if you had divided the first by the second. Don't worry, you don't actually have to divide, and don't worry about negative numbers for now. So none of the inputs are going to be negative. So let's think about this. Yes, I can tell you are an enterprising worker. I haven't been home in about 25 years either. So the first number, let's go ahead and just copy to this, and we'll name this first. And then this one will be second. And then this one will be remainder. Or just remain for short. So, inbox 1, copy it to first. Inbox 2, copy it to second. And then division, like multiplication, is just subtraction, except for you don't go into the negative. So all we need to do then is subtract from 1. If it's negative, jump to the point where we copy from the remainder and outbox. If it's positive, instead copy it to the remainder and then copy and then jump back to this point where we subtract from 1 again and see if it's negative again. What was the optimization challenge here? 12? Well, I think I've got it done in 11. If I've done this right. Of course, if it was 0, the right move here would be to put a jump of 0 too, just in case it equals, actually equals the number and there is no remainder. If it actually is 0, I need to jump to a different place, actually. Come to think of it. Need to jump to outbox. Copy to first and copy to remainder. I guess we don't need to copy the second at all. Let's just get rid of second. 12 commands, that's what we're at. 9, then we subtract from 4. That gives us 4, and that's wrong. So if it's a negative number, I think the problem is we're going the wrong direction. Is that it? Put a 5 here, and then we subtract a 2, and that should give us 3. Let's see, jump if negative this way. I think we have to copy from remain here and try that. 5 goes down here. We subtract 3 from it. It gives us negative 2. Let's try it this way. Put down that 8, then we put down the 4. We take this, subtract, that gives us 4. Well, that's certainly not going to work. Two minus 7 is right. So this should subtract 4 from 9, it should give us 5. But instead it gives us negative 5. Which is weird. And that's really where I just feel like they've done this totally wrong. I guess we do it like this. Then put 6 down on first. Take this 3, put it down here. Then take this, subtract. Put that down here. Take this, take that. All we have is 0. Take this, subtract, and then we're at negative 3, which gives us 3. So we do still need a jump if 0 to the outbox as a solution. But then that puts us over to 12, so we're using something extra, which we don't need to do. But let's see, what did we do wrong there? We copied from remain when we needed to copy from this, and I'm not sure if there's something else we're missing. We take this, put it there. We take the other one, put it here. Subtract from that, which we have to do. That's a negative number. That gives us the right number. So maybe we now can get rid of the jump of 0 command. That's the only thing I could think that would get it down. See, if we have a 0 here and a 3 here, subtracting that gives you a negative number and then gives us 0. I don't understand that 0 code at all, actually. Let's just go ahead and take this out and see if it still works. We can always hit the undo button. So yes, that works. Notice we have a different boss this time. 20, did we do it in less than 57 steps? No, we're 3 steps away. So how could we save ourselves some steps? Sometimes you can just do something that makes no sense, like take the top 3 inbox things in this case, and well, the top 4, and then just have this jump to this point. Why that would save you a few steps, I don't know. It seems like you're doing the exact same action, but let's see if it does. It is kind of assuming you're gonna inbox something more. That got me down to 60. 60 is less than where we were, but that's certainly not enough. So we just continue down this road and put the rest of the program in here to double it up. Division. There might be also a way of doing this that would make more sense if I made a special case for zeros. That could be it. Copy from first and outbox is the only 2 commands I think I need left. So let's see if this works. I actually need to jump back up to this point. Will that get us below 60? We almost have double the lines of code. Yes, it gets us to 57. So, is there really a reason to sit here and think of a smarter way to do it? No. So we just move on to cumulative countdown. I'm making more progress actually than I thought I was going to. What is the purpose of this assignment? I think it's something about calculating the volume beneath staircases. We have to put the interns somewhere. For each thing in the inbox, outbox, the sum of itself plus all the numbers down to 0. for example, if the inbox is 3, outbox should be 6, because 3 plus 2 plus 1 equals 6. So this is a series mathematical calculation that is uh, pretty complicated. We have a vast stairwell here. Oh, did you take the elevator? Well, nice of you to show up. So, that's a little odd joke, but it's kind of funny. We take this and we copy it to the thing we'll just call the number. Here we go, the number. And then what we'll do is also copy it to something we'll call the sum. We'll then bump the number, and if it's 0, jump out of this loop, otherwise jump back into the loop and simply add this to the sum, copy it to the sum, and then let's see, copy the number from number, because this bump will actually affect that. Yeah. So that's 9 things of code. We need 12, it says, so we're going to add to a few steps. Give me an example. If your inbox is 3, 1, and 0, and 5, it should be 6, 1, 0, and 15. We need an outbox here, and we need a jump here, and that's 11 out of 12. Seems right. Let's try. 4 gets put here, bump it down to 3, and then add. Actually, I don't need the copy from, do I? I was expecting 10, but I outboxed 0. Okay, so we don't need that there, but we do need this here. So let's try that again. 4, 4. Bump it down to 3. Already get a copy. Add it, put it down. Bump it down. Add it, put it down. Bump it down. Add it, put it down. Bump it down. It's at 0. Grab that 10. Outbox. Done. Let's just speed it up. How come the numbers are going negative? This is the problem with speeding up, though, is something didn't work there. I think we need a special case in case we get the number 0 on the inbox. Yeah, that is an easy solution. So jump of 0, outbox, and then go back. 3 gets added to 2, gets added to 1, that's 6. We grab the 6 and we go. 4 gets added to 3, gets added to 2, which then gets added to 1, which gives us 10. And so in mathematics, I believe you put a little I next to something when you want to include a series of every number going upward. So if you put like 2, no, going downward, 2I would be 2, 1, 0. I think that's it. They actually never taught me in any of my math classes about series, as far as I remember. They probably did. Maybe they covered it in a different way and didn't use the I. It's high level calculus for sure. And It's nice to see it mentioned here, but not covered in any way. Nothing here is being covered. You're just getting tiny little snippets of of interesting things, and then they're leaving you alone to learn on your own. So we got both of those on the first try. Let's move the small divide. Remember the last time when I told you we didn't need to divide? Okay, now we need to divide. Well, now you get to. For each two things in the outbox, how many times does the second fully fit into the first? Don't worry about negative numbers. Divide by 0 or remainders. There is an error in games, in programming, called the divide by 0 error, because if you divide by 0, it would go on forever and then crash your computer. Self-improvement tip. This might be a good time to practice copying and pasting from a previous assignment. I agree. So let's just go to this mod module and start with what we have here. So click here and paste it. Tell me more. Yes, you might notice this assignment is similar to the one we worked on together one evening not long ago. You may go back and review your work if you like. Did you know you can also copy and paste? Before you get any ideas, please note that we keep a strict inventory of the office supply cabinet. What that means, I don't get the joke there. If your inbox is 748239 and 0 and 4, 4 goes into 7 once, and let's see, 2 goes into 8 4 times, and then 9 goes into 3 0 times, and 4 goes into 0 0 times. Okay. So I think what we need to do is copy from this and put it here, and we're going to call this count. And what we'll do is each time it's good, we'll bump up count, and then we will just simply copy from count here. And since this code is already been doubled out, we'll just change it twice. Why is this copy from count? Let's see. Oh, I need to drag these down this way. We'll put a little marker to mark the middle point where the code is doubled. Bump up count there, and then copy from count there. That should be it. So it puts a 0 here. Every time it can successfully go into something, it's going to tell us, hopefully. 6 minus 4 is a small enough number, so we bump up that. Now, 4 minus 2 doesn't work, so that should be right. Now, just replaces this with 0 again to start over. And this should work. This should be 0. But no, it's 1. I did it wrong. The way they subtract really throws me for a loop. Make a lot more sense to me. But as you may have noticed at this point, sometimes I just program completely out of order, backwards, forwards, put a code here, put a code there, add something in the middle that I was planning on doing later. This one didn't work. What changed? So 3 divided by this is a negative number, and that jumps here, but should I have jumped it there? Or should I have bumped? Just watch it a little bit more carefully here. Puts the 0 here. Puts the 9 down. Puts the 2 down. Subtract that from that. That gives us 7. Bumps that up. This minus this gives us 5. Bumps that up again. Subtract that from that. Gives us 3. 1. 4. So that's good. And I think that's the same math problem here, so let's just skip. Wait a minute, something went wrong here. Nine should be subtracted from 2, and that should then go to first, and then I should bump count, and then this should jump up. This one here should jump up the copy from first. How that was in the wrong place, I don't know. We grab the 6 here. We put it here. And I happen to notice this is not 0. So and I can tell you why right now because of that. Alright, good. There we go, the code runs. Small divide done. Did we do it in 15 or fewer things? No. Did we do it in 76 or fewer steps? Yes. Good. So now it's not that difficult to simply remove everything here and get the code down to 15. Since that was just duplicated code for the purpose of speed. This one and this one. And it's exactly at 15. Hit play, go. It'll take more steps this way, a few more steps. But you really don't program thinking of the number of steps. It's not a factor that matters. Also, as you make your program more complicated than very basic mathematical things, hey, I got them both in that, so I didn't even need to duplicate it. You don't know what your inputs are going to be. And when you don't know what your inputs are going to be, that all of a sudden makes it unrealistic to count steps. I suppose we should watch this. It'll give me a chance to rest my voice for a second. Take another sip. I hate being on the verge of coughing. Just look at what this place looks like now. Mouse, out of the way, mouse. Look how bad she looks. It's not a moon, it's an eyeball. Or, yeah, it's a giant robot eyeball. Also, take note there's no power in the building at all. So here we are doing programs year after year, and outside in the world, apparently robots have taken over. And we haven't even taken notice of it. So, three sort is an interesting one. Uh, to We'll probably end the recording on this one. This was the first of the three puzzles that I could not figure out at all. It was three sort that I had to cheat on, digit exploder to get one challenge done, and prime factory to get done at all. Actually, I did do three sort, but then I couldn't get the speed challenge on it. So I did like the speed challenge for digit exploder and prime factory, and everything on prime factory I cheated on. Not particularly because I couldn't have gotten it done, just because I just couldn't bother to spend any more time on it before even recording the first episode. But let's do three sort, talk about it at least before I show you the solution. Yes, we rank our employees here from worst performing all the way to best performing. Where do you rank? Let's give it some thought while we complete this assignment. For each three things in the inbox, send them to the outbox in the order from smallest to largest. Okay, so and they even give you the beginning. Inbox copy to 0, and inbox copy to 1, and inbox copy uh, to 2. So we'll just label this first, second, and third. If that really helps us, I'm not sure. Tell me more. Yes, you need to sort sets of numbers. Don't worry. Our data resources have no feeling, which we find to be convenient. Give me an example. If your inbox was 742, you would send out 247. If then it was 158, you'd send out 158. If it's then 3, 6, -5, you would send -5, 3, and 6. Notice no absolute value here. We never do anything with absolute value, and it's kind of missing that there is one where it says just give us the number. If it's negative, make it positive at the very beginning, but that's the only time we really use that, and they don't say the phrase absolute value. If the inbox is -2, 7, -4, you have to go -4, -2, -7. So again, this is where I probably suffered from being confused by least to smallest, where in my mind, even though it's wrong, I would think a -4 is more than a -2, at least at the first second of glancing at it. But that's not it. It's furthest left on the number line to furthest right on the number line. So what I guess we'll do is we'll subtract this, and if it's negative, we would put it in a temp place, and if it's positive, let's see, if it's positive, we need to add it back to get the number, and then copy to 2. If it's negative, we're going to add it back, and copy to 2. Well, no, copy to temp. No, So add it back to first, copy the temp, copy from the first one to the second one. Then we should be okay to do something different. So then this one needs to be subtracted, I guess, again the first. If it's negative, then go somewhere over here, otherwise add it back and then subtract it from number 2. If it's negative, then go here. Let's see, I think this line of code, this is where labeling probably would be somewhat helpful. So if this is negative on the second one, then don't we need to copy to temp and then subtract from this. If it's negative, do the same as if it's negative here, but if it's positive, then just copy from this and put it here, and then copy from temp and put it here. And if it's negative, then copy to temp and copy from if it's negative, I think you just need to then copy it to third. Maybe? Let's go ahead and put a copy from 1 first, copy from second, and copy from third with the outboxes, and give this a whirl. See how much of that math we just put in here is right. We put the 8 down, we subtract, is it negative? Yes. So we put that there and that there. Wait, we did something wrong there. We put, let's see, we copied to 2 here. But then we also need to copy from temp to first. And let's play again. 7 here, 5 here, put this there, switch things around. Is it necessary to switch things around, or maybe we should work things backwards and just read from third, second, and first? Maybe that would just save us some time. They were expecting 1 and they got 5. What happened to there? 1 minus this, jumps if negative, and then copies that to temp. Nope, don't copy that to temp. Add it to first, then copy it to temp. 9, subtract this to switch those around, There's a lot of switching around going on here. Nope. 8. Subtract this. Switch that around. Again, wrong. Like, when I get a negative number here, well, actually, when I get a negative number here, I should copy it to temp, and then subtract it from second. And if it was negative, I think we do this. But since it's positive, I think all we do is add it back to second, copy to temp, copy from this to this, copy from this to this, and then copy from temp to first. Let's try that. 9. This is smaller, so it should move everything around. I think they're intentionally in the first set giving you numbers backwards. This point is sort of right. But not quite. So this jump of negative should then be something like copy to temp after we add back the second, well, the first number, and then copy to temp, and then copy from the first to the second, and then copy from temp to the first. Let's try this again. 9 gets put down, that's right. 6 subtracts, finds out it's smaller, does the swaparoo. 1 comes in, tests this. Finds out it's smaller, puts this down, takes this, doesn't need to actually test that, while that code works, it's actually not doing it very efficiently. So I want to hit play again and see where the code goes wrong here. This is right. That's right. So that's good. Now this adds this, puts that there, and we don't need this part. We don't need to subtract to see if it's negative, add to. We can simply say copy to temp. So let's hope that works now. 7, 5, tells them swatch it, swap. Unfortunately, we're getting the same situation each time as the first input, so we'll have to wait for the program to move itself along to the second solution before we can see new scenarios. I think I've optimized that enough. The last thing to do would be to ask the question, are we done? Let's see. Will this always work? So we're just listening for the ding ding ding. We expected 1, but we outboxed 0. So we want either the dong or the ding there. And let's see. So let's start here again. We take the 1, we copy it to first. Good. We take this, we subtract. It's a positive number this time, so we add first and copy it to second. So it's 1, 5 now. Then we inbox. We subtract the first. It's a positive number. So we subtract second. And then we put it down. And I don't believe that's right. I think we need to add second back into it. Don't we? Let's see if that fixes it. Something about it caused it to skip outboxing a significant portion of that code. It sorted it, it just didn't outbox it. Alright, so the last thing we outbox is here, and then we jump here and we inbox 1. We put it in first. We inbox 4. We subtract, find it's a positive number. We add back, put it in the second spot. We inbox the third thing. We subtract this, see it's a positive number, add it back, subtract this, see it's still a positive number, add back, and then we copy the 3. And at that point, there's no more things need to be done, so I'll just jump to this. Maybe that was what I was missing. In an effort just to save time, you end up fast forwarding to a speed that makes no sense. So this is 1, 3, 1. 1 is correct. 3 is right. Wrong. It should be 1, 1, 3, because the 3 inputs were 1, 1, 3. Interesting. Yep. The 3 inputs were 3, 1, 1. So let's watch what happens. Puts a 3 here, puts it down. Takes this, subtracts it. Sees it's a negative number, swaps it around. That's right. So next one it gets is this. It sees that's a 0, so it adds that. It sees this as a negative, and then it jumps to this code, which is going to add to it, and then copy to it. And that's the wrong code. It needs to add it, copy to temp, copy from second to third, and then copy from temp to second. What's the optimization challenge here? 34? I'm up to 60. Wow. So you can kind of see why the optimization issue here is not working very well, and I didn't figure it out myself. It seems like a lot of times working backwards would be the right way. And there may be some other tricks we could do. Since we have 9 carpet tiles, 9 memory addresses we could potentially work with, I could see things changing. So this looks like it's gonna work. Let's speed it up. So there's 3 sort, and I did get this done by myself, but I don't think I got the speed challenge done by myself. I probably got the size challenge done. What could we do to reduce the speed? Hard to tell. There's a few scenarios here where like copy to first is not necessary. This could simply just outbox, and that would take out 1. Let's see, where else? Maybe we could copy to first here. Again, not necessary. We could simply just outbox that one. Copy to first here. That jumps up to that point is necessary. This jump could be eliminated. Several of these jumps could be eliminated for size, but how would we even get it to 37? Like, we spent 60 commands there, and we're closer to the speed challenges, and this is a great example again of where we don't have to spend another 30 minutes looking at this when I can just load up my save file and before and get the answer. Let's see. We have, this one's the cheater. This was what I had before. This one's number 1 that I did. And I don't believe this one ever worked. But let's see. So number 1 we'll run through and see what it does. Different. It just puts the 3 here, then tests the middle one, says, well, that one doesn't work, so we'll swap it around. Then it comes around and tests that. It says, well, that one is bigger, so we'll do that. And then we'll switch that around. Now we take this and we swap this around and test that and do that. And so I'm being a little bit different about the order in which I test everything, and that honestly that feels like it tested more than the code I just wrote, but it still works. Let's see how many steps and such it took. This seems like it's optimized to be a short code. So I did that in 34 commands this time and 125 steps. So let's go ahead and copy this and then go back to the previous save file. This is the problem. Here's the copy and paste between two save files is not fast. Notice my hair is now gray after the midnight thing. So we'll just paste that there, hit that, hit play. So I don't look like I have gray hair here, but next puzzle I probably will. Or white hair. But profoundly bald. So 125 steps to get that one done. Let's get back out. And this is my first cheat. See? Gray hair. I was frankly frustrated at this point. You can see this is obviously somebody else's labeling of things, that because they have a different style, probably better of drawing those labels, and they actually label things, which I'm pretty bad at. I actually once was in a situation where I was dealing with having to yet again prove that I knew what I was doing as far as programming, and it was in an educational situation, and the educator was taking off points and giving me a lower score because I was not labeling things, because I was going beyond what they wanted to see. So it was rather frustrating, and it became rather obvious immediately to me that this teacher was simply grading versus a test sheet. So anything that was even slightly away from the test sheet, she was marking as wrong. And also it became kind of obvious that she didn't really know what she was doing, because she was like the wife of the head of the department. So it was just nepotism, how she was doing it. And she was teaching entry-level C++ programming versus the one she liked to teach was HTML, I think. So rather frustrating. That happened to me twice in my education. I had taken like keyboarding in middle school, and then I had to take it again in high school. Not a big problem though. I mean, if there's one class you can repeat, it's keyboarding, and it will just make you a faster keyboarder, typist. So I think the labels kind of explain what he's doing here to save spaces. He's run code specifically for each scenario. So if B is less than C, if A is less than B, if C is less than B, every situation that may come apart, he has rewritten the code in a slightly different order, and it's taken him 58 steps to do that, but it got it down to uh, 75 steps, which is what the goal was. I certainly could have done this. I just didn't feel like it being worth it, really. Like, it really isn't that worth it to have three different outputs here: a BAC, a BCA, and a BCA or a CCB. Uh, and then here's ACB or CCA uh, code. Here's ACB output. Here's ABC output. Here's ACB uh, output. No, some of this is actually A is less than B or A is less than C, so it outputs the A first, and then it copies C and sees that A less than B. Um, so, yeah, I could have done that. I certainly could have done any of these, and that gets that done. And that leaves us for storage floor next time. So, starting on the green path, it's more about strings and letters, although Digit Exploder and Prime Factory are numbers, and incredibly difficult extra puzzles. Everything else is more about manipulating letters, and that's nice. So you start with this easy yellow path, you do the blue path, which is mostly math, and then you're into characters, letters. But if you couldn't have done the math, which frankly may have been in some places more difficult than the letters, you would have never gotten through the levels. This game desperately needs a cheat system. It desperately needs an ability to skip levels. You could have gotten stuck at any one of the ones between 7 and 25 and never even seen the second third of the game. And that's not acceptable. It really isn't. Anywho, that's going to be it for this recording. As always, I ask you to like, share, subscribe, comment if you want to, and watch every second of my videos. All that helps me out. If you want to support me, you can click on my name, Rydo. On the right will be a blue button that says support this channel. Click it, make a donation. And if you want to friend or follow me on basically any social media sites, there's a whole bunch of links down below. Thank you for watching. Have a good evening.